Hi, it's Mrs. Corajanis. This is lesson topic 3-1. This is example 2. Analyze reasonable domains and ranges and try it. All right. So right here it says a function can model each situation. What is a reasonable domain and range of each function? So what that means is what is a domain that would fit into this function, okay? And I'll explain it better as we go through it. And what is a range that can fit into this function? So what are the numbers for the range and the numbers for the domain that are going to make sense for this story, all right? So let's read the first one right here. And that one says, a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So the first thing that you want to do is decide which one is your dependent variable and which one is your independent variable. Okay, so your dependent variable and your independent variable. And there's a couple ways I usually think about this. As I think about, I restructure this. So what depends on what? So a hose fills a 10,000 gallon swimming pool at a rate of 10 gallons per minute. So the gallons depend on the minute. Okay. So I think about it like that. So what depends on what? Okay. So the gallons depend on the minutes. So that means the dependent variable are the gallons of water. And the independent variable is your minutes. Now, if I were to graph this, my x-axis is here, my y-axis is here. My independent variable is the x. I think I spelled that wrong. Give me 1 second. Independent. Okay, this is my domain. And my dependent is my range. Okay, so my minutes go here. And my gallons go here at the Y. Let me put it here. Okay, so now that I know that, a reasonable domain. So the reasonable domain. So this is my domain, the minutes. So it says, what is a reasonable domain? So think about it like this. Can I have negative minutes, right? Well, the answer to that is no, I can't have negative minutes. So since I can't have negative minutes, what is the least amount of minutes that I can have? Well, the least amount of minutes, let's think about it like this. So the least amount of minutes, so this is for my domain. The least amount of minutes is 0 minutes. What is the most amount of minutes? Well, I mean, I guess that can keep going on to infinity. I mean, I don't know what it is yet. So it's 0 to the time it takes to fill. Okay, So that is your domain. So my domain is 0 to the time it takes to fill the pool. Now my range is so my range is rate of 10 gallons. Okay, so my range is the gallons, right? So what is the least amount of gallons that I can have? So my range is the least amount of gallons is 0. Okay, that's the least amount. I can't have negative gallons of water, so the least amount is 0. Well, what is the greatest amount? The greatest amount is 10,000. So the greatest is 10,000. Okay. So oh, I learned how to erase everything. All right. So right here again, so the domain is our minutes. And a reasonable domain is it's going to be from least to greatest. So it's going to be 0 to whatever time it takes. Okay? So we'll say 0 to question mark time it takes to fill. We'll say let's see if it's 10,000 if it's 10,000 gallons. Okay, let's say it's going to be 1,000 minutes. Okay, I think that's what it's going to take is 1,000 minutes. Now your range is your gallons. And what is the least amount of gallons? The least amount of gallons is 0. To the greatest amount is 10,000 gallons. Okay, so this is just a thinking problem. All right, let's do the restaurant one. So, figured it out. That's cool. All right, so a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So what we want to do is we want to figure out what the dependent variable is. And we want to figure out what the independent variable is. So the dependent variable is so restaurant, so let's blank depends on blank. Okay, so a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. So the chairs depend on the tables. If we were to graph this is our X, this is our Y. Our X is our independent. So chairs are the dependent. So chairs depend on it. So chairs go in the Y. And X are your tables. Okay. So let's think about a reasonable domain. So domain. So your domain are your tables. So your least to your greatest. So your least amount of tables is 0 to what is the greatest number of tables? We don't know. So 0 to, we'll say infinity. Because we can have I guess, infinitely many tables, or let's say the restaurant only has 20 tables, then your domain would be 0 to 20. Okay, so we really don't know. Okay, and then your range is again least to greatest. Well, what's the least amount of chairs? The least amount of chairs is 0. So 0 to, well, let's say infinity again. Only if we had a certain amount of chairs, like if a restaurant only had like I don't know. I think I said 20 tables, right? So let's say they had 100 chairs. So then your range would be 0 to 100. So this one your domain would be 0 to 20 if your restaurant only had 20 chairs. And we'll talk about that notation in a minute. And then for your range, it would be 0 to, let's say, 100 if they had 100 chairs altogether. All right. So then example 2, this one here, let me erase this. Continuous and discrete. You can go through this one on your own because we're not going to use this yet. And then go ahead and go to the triad. So it says analyze each situation, identify a reasonable domain and range for each situation, explain. So the first thing you want to do for each of them is decide which one your dependent variable is and which one your independent variable is. So when you're doing these, write that in here and then try your best. Okay?